Intel Active Management Technology is hardware-based technology for remotely managing and securing PCs out of band. Currently, Intel AMT is available in desktops, servers, ultrabooks, tablets, and laptops with Intel Core vPro processor family, including Intel Core i3, i5, i7, and Intel Xeon processor E3-1200 product family. Overview of Intel AMT. Intel AMT is hardware and firmware technology that builds certain functionality into business PCs in order to monitor, maintain, update, upgrade, and repair PCs. Intel AMT is part of the Intel Management Engine, which is built into PCs with Intel vPro technology. Intel AMT is designed into a secondary processor located on the motherboard. Intel AMT has moved towards increasing support for DMTF desktop and mobile architecture for system hardware standards, and AMT Release 5.1 and later releases are an implementation of version 1.0/1.1 standards for out-of-band management. AMT provides similar functionality to IPMI, although AMT is designed for client computing systems as compared with the typically server-based IPMI. AMT is not intended to be used by itself. It is intended to be used with a software management application. It gives a management application better access to the PC down the wire, in order to remotely and securely do tasks that are difficult or sometimes impossible when working on a PC that does not have remote functionalities built into it. Hardware-based management and software-based management. Hardware-based management is different from software-based management and software management agents. Hardware-based management works at a different level than software applications, uses a communication channel that is different from software-based communication. Hardware-based management does not depend on the presence of an OS or locally installed management agent. Hardware-based management has been available on Intel AMD-based computers in the past, but it has largely been limited to auto-configuration using DHCP or BOOTP for dynamic IP allocation and diskless workstations, as well as Wake on LAN for remotely powering on systems. Intel AMT uses TLS secured communication and strong encryption, to provide additional security. Intel AMT features. Intel AMT includes hardware-based remote management, security, power management, and remote configuration features. These features allow an IT technician to access an AMT-featured PC remotely. Intel AMT relies on a hardware-based out-of-band communication channel that operates below the OS level. The channel is independent of the state of the OS. The communication channel is also independent of the PC's power state, the presence of a management agent, and the state of many hardware components. Most AMT features are available OOB, regardless of PC power state. Other features require the PC to be powered up, agent presence checking, and network traffic filtering. Intel AMT has remote power-up capability. Hardware-based features can be combined with scripting to automate maintenance and service. Hardware-based AMT features in laptop and desktop PCs. Hardware-based AMT features include encrypted, remote communication channel for network traffic between the IT console and Intel AMT. Ability for a wired PC outside the company's firewall on an open LAN to establish a secure communication tunnel back to the IT console. Examples of an open LAN include a wired laptop at home or at an SMB site that does not have a proxy server. Remote power-up/power down/power cycle through encrypted WOL. Remote boot, via integrated device electronics redirect. Console redirection, via serial over LAN. Keyboard, video, mouse over network. Hardware-based filters for monitoring packet headers in inbound and outbound network traffic for known threats, and for monitoring known/unknown threats based on time-based heuristics. Laptops and desktop PCs have filters to monitor packet headers. Desktop PCs have packet header filters and time-based filters. Isolation circuitry to port block, rate limit, or fully isolate a PC that might be compromised or infected. Agent presence checking, via hardware-based, policy-based programmable timers. A miss generates an event. You can specify that the event generate an alert. OOB alerting. Persistent event log, stored in protected memory. Access the PC's universal unique identifier. Access hardware asset information, such as a component's manufacturer and model, which is updated every time the system goes through power-on self-test. Access to third-party data store, a protected memory area that software vendors can use, in which to version information, DAT files, and other information. Remote configuration options, including certificate-based zero-touch remote configuration, USB key configuration, and manual configuration. Protected audio-video pathway for playback protection of DRM-protected media. Additional AMT features in laptop PCs. Laptops with AMT also include wireless technologies, support for IEEE 800 2.11 and wireless protocols, Cisco-compatible extensions for voice over WLAN, Intel vPro platform features. Intel AMT is security and management technology that is built into PCs with Intel vPro technology. PCs with Intel vPro include many other platform technologies and features. Using Intel AMT, almost all AMT features are available even if PC power is off, the OS is crashed, the software agent is missing, or hardware has failed. The console redirection feature, agent presence checking, and network traffic filters are available after the PC is powered up. Intel AMT supports these management tasks: remotely power up, power down, power cycle, and power reset the computer. Remote boot the PC by remotely redirecting the PC a unregistered trademark S boot process, causing it to boot from a different image, such as a network share, bootable CD-ROM or DVD, remediation drive, or other boot device. This feature supports remote booting a PC that has a corrupted or missing OS. Remotely redirect the system unregistered trademark SIO via console redirection through serial over LAN. This feature supports remote troubleshooting, remote repair, software upgrades, and similar processes. Access and change BIOS settings remotely. This feature is available even if PC power is off, the OS is down, or hardware has failed. This feature is designed to allow remote updates and corrections of configuration settings. This feature supports full BIOS updates, not just changes to specific settings. Detect suspicious network traffic. In laptop and desktop PCs, this feature allows a sysadmin to define the events that might indicate an inbound or outbound threat in a network packet header. In desktop PCs, this feature also supports detection of known and or unknown threats in network traffic via time-based, heuristics-based filters. Network traffic is checked before it reaches the OS, so it is also checked before the OS and software applications load, and after they shut down. Block or rate limit network traffic to and from systems suspected of being infected or compromised by computer viruses, computer worms, or other threats. This feature uses Intel AMT hardware-based isolation circuitry that can be triggered manually or automatically, based on IT policy. Manage hardware packet filters in the onboard network adapter. Automatically send OOB communication to the IT console when a critical software agent misses its assigned check and with the programmable, policy-based hardware-based timer. A miss indicates a potential problem. This feature can be combined with OOB alerting so that the IT console is notified only when a potential problem occurs. Receive platform event trap events out of band from the AMT subsystem. You can alert on an event or on a threshold. Access a persistent event log, stored in protected memory. The event log is available OOB, even if the OS is down or the hardware has already failed. Discover an AMT system independently of the PC's power state or OS state. Discovery is available if the system is powered down, its OS is compromised or down, hardware has failed, or management agents are missing. Perform a software inventory or access information about software on the PC. This feature allows a third-party software vendor to store software asset or version information for local applications in the Intel AMT protected memory. The third-party data store can be accessed OOB by the sysadmin. For example, an antivirus program could store version information in the protected memory that is available for third-party data. A computer script could use this feature to identify PCs that need to be updated. Perform a hardware inventory by uploading the remote PC's hardware asset list. Hardware asset information is updated every time the system runs through power-on self-test. VNC-based KVM remote control. From major version 6, Intel AMT embeds a proprietary VNC server, so you can connect out-of-band using dedicated VNC-compatible viewer technology, and have full KVM capability throughout the power cycle, including uninterrupted control of the desktop when an operating system loads. Clients such as VNC Viewer Plus from Real VNC also provide additional functionality that might make it easier to perform certain Intel AMT operations, such as powering the computer off and on, configuring the BIOS, and mounting a remote image. Out-of-band communication with AMT. Intel AMT is part of the Intel Management Engine. All access to the Intel AMT features is through the Intel Management Engine in the PC unregistered trademark S hardware and firmware. AMT communication depends on the state of the management engine, not the state of the PC unregistered trademark SOS. As part of the Intel Management Engine, the AMT OOB communication channel is based on the TCP/IP firmware stack designed into system hardware. Because it is based on the TCP/IP stack, remote communication with AMT occurs via the network data path before communication is passed to the OS. AMT out-of-band communication for wired versus wireless PCs. Intel AMT supports wired and wireless networks. For wireless notebooks on battery power, OOB communication is available when the system is awake and connected to the corporate network, even if the OS is down. OOB communication is also available for wireless or wired notebooks connected to the corporate network over a host OS-based virtual private network when notebooks are awake and working properly. AMT out-of-band secure communication outside the corporate firewall. AMT version 4.0 and higher can establish a secure communication tunnel between a wired PC and an IT console outside the corporate firewall. In this scheme, a management presence server authenticates the PC, opens a secure TLS tunnel between the IT console and the PC, and mediates communication. The scheme is intended to help the user or PC itself request maintenance or service when at satellite offices or similar places where there is no on-site proxy server or management appliance. Technology that secures communications outside a corporate firewall is relatively new. It also requires that an infrastructure be in place, including support from IT consoles and firewalls. How it works: an AMT PC stores system configuration information in protected memory. For PCs version 4.0 and higher, this information can include the name, of appropriate whitelist management servers for the company. When a user tries to initiate a remote session between the wired PC and a company server from an open LAN, AMT sends the stored information to a management presence server in the demilitarized zone that exists between the corporate firewall and client firewalls. The MPS uses that information to help authenticate the PC. The MPS then mediates communication between the laptop and the companion unregistered trademark S management servers. Because communication is authenticated, a secure communication tunnel can then be opened using TLS encryption. Once secure communications are established between the IT console and Intel AMT on the user's PC, a sysadmin can use the typical AMT features to remotely diagnose, repair, maintain, or update the PC. Intel AMT security: because AMT allows access to the PC below the OS level, security for the AMT features is a key concern. Security for communications between Intel AMT and the provisioning service and/or management console can be established in different ways depending on the network environment. Security can be established via certificates and keys, pre-shared keys, or administrator password. Security technologies that protect access to the AMT features are built into the hardware and firmware. As with other hardware-based features of AMT, the security technologies are active even if the PC is powered off, the OS is crashed, software agents are missing, or hardware has failed. Using AMT in a secure network environment, because in-band remote management does not usually occur over a secured network communication channel, businesses have typically had to choose between having a secure network or allowing IT to use remote management applications without secure communications to maintain and service PCs. Modern security technologies and hardware designs allow remote management even in more secure environments. For example, Intel AMT supports IEEE 800 2.1x, pre-boot execution environment, Cisco SDN, and Microsoft NAP. All AMT features are available in a secure network environment. With Intel AMT in the secure network environment, the network can verify the security posture of an AMT-enabled PC and authenticate the PC before the OS loads and before the PC is allowed access to the network. PXE boot can be used while maintaining network security. In other words, an IT administrator can use an existing PXE infrastructure in an IEEE 800 2.1x, Cisco SDN, or Microsoft NAP network. Intel AMT in a secured network environment. How it works: Intel AMT can embed network security credentials in the hardware, via the Intel AMT Embedded Trust Agent and an AMT Posture plugin. The plugin collects security posture information, such as firmware configuration and security parameters from third-party software, BIOS, and protected memory. The plugin and trust agent can store the security profile, S, in AMT's protected, non-volatile memory, which is not on the hard disk drive. Because AMT has an out-of-band communication channel, AMT can present the PC's security posture to the network even if the PC's OS or security software is compromised. Since AMT presents the posture out of band, the network can also authenticate the PC out of band, before the OS or applications load and before they try to access the network. If the security posture is not correct, a system administrator can push an update OOB or reinstall critical security software before letting the PC access the network. Security postures supported by Intel AMT versions. Support for different security postures depends on the AMT release. Support for IEEE 800 2.1x and Cisco SDN requires AMT version 2.6 or higher for laptops, and AMT version 3.0 or higher for desktop PCs. Support for Microsoft NAP requires AMT version 4.0 or higher. Support for PXE boot with full network security requires AMT version 3.2 or higher for desktop PCs. Intel AMT security technologies and methodologies. AMT includes several security schemes, technologies, and methodologies to secure access to the AMT features during deployment and during remote management. AMT security technologies and methodologies include transport layer security, including pre-shared key TLS, HTTP authentication, single sign-on to Intel AMT with Microsoft Windows domain authentication, based on Microsoft Active Directory and Kerberos, digitally signed firmware, pseudo-random number generator which generates session keys, protected memory for critical system data, such as the UUID, hardware asset information, and BIOS configuration settings, access control lists. As with other aspects of Intel AMT, the security technologies and methodologies are built into the chipset. Known vulnerabilities and exploits. A-3 rootkit was demonstrated by Invisible Things Lab for the Q35 chipset. It does not work for the later Q45 chipset as Intel implemented additional protections. The exploit worked by remapping the normally protected memory region reserved for the ME. The ME rootkit could be installed regardless of whether the AMT is present or enabled on the system, as the chipset always contains the ARCME coprocessor. For the vulnerable Q35 chipset, a keystroke logger ME-based rootkit was demonstrated by Patrick Stewin. Another security evaluation by Vasilios Ververis showed serious weaknesses in the GM45 chipset implementation. In particular, it criticized AMT for transmitting unencrypted passwords in the SMB provisioning mode when the IDE redirection and serial over LAN features are used. It also found that the zero-touch provisioning mode is still enabled even when the AMT appears to be disabled in BIOS. For about €60, Ververis purchased from GoDaddy a certificate that is accepted by VME firmware and allows remote zero-touch provisioning of machines, which broadcast their hello packets to would-be configuration servers. Versions. Software updates provide upgrades to the next minor version of Intel AMT. New major releases of Intel AMT are built into a new chipset, and are updated through new hardware. Management Engine. The Management Engine is an isolated and protected coprocessor, embedded in the Intel chipsets. According to an independent analysis by Igor Skakinski, it is based on an ARC core, and the Management Engine runs the Thread XRTOS from Express Logic. According to this analysis, versions 1x to 5x of the ME use the Arctangent A4 whereas versions 6x to 8x use the newer Arcompact. Starting with ME 7.1. The ARC processor can also execute signed Java applets. The ME state is stored in a partition of the SPI flash, using the embedded flash file system. The ME has its own MAC and IP address for the out-of-band interface, with direct access to the Ethernet controller. One portion of the Ethernet traffic is diverted to the ME even before reaching the host's operating system, for what support exists in various Ethernet controllers, exported and made configurable via Management Component Transport Protocol. The ME also communicates with the host via PCI interface. Under Linux, communication between the host and the ME is done via MEI. Until the release of Nehalem processors, the ME was usually embedded into the motherboard's North Bridge, following the memory controller hub layout. With the newer Intel architectures, ME is included into the platform controller hub. Firmware modules, active management technology, alert standard format, quiet system technology, formerly known as advanced fan speed control, which provides support for acoustically optimized fan speed control, and monitoring of temperature, voltage, current and fan speed sensors that are provided in the chipset, CPU and other devices present on the motherboard. Communication with the QST firmware subsystem is documented and available through the official software development kit. Trusted Platform Module, provisioning and integration of Intel AMT. AMT supports certificate-based or PSK-based remote provisioning, USB key-based provisioning, manual provisioning and provisioning using an agent on the local host. An OEM can also pre-provision AMT. The current version of AMT supports remote deployment on both laptop and desktop PCs. Remote deployment, until recently, was only possible within a corporate network. Remote deployment lets a sysadmin deploy PCs without touching the systems physically. It also allows a sysadmin to delay deployments and put PCs into use for a period of time before making AMT features available to the IT console. As delivery and deployment models evolve, AMT can now be deployed over the Internet, using both zero-touch and host-based methods. Intel vPro PCs can be sold with AMT enabled or disabled. PCs with Intel AMT can be sold with AMT enabled or disabled. The OEM determines whether to ship AMT with the capabilities ready for setup or disabled. Your setup and configuration process will vary, depending on the OEM build. Intel AMT includes a privacy icon application, called IMSS, that notifies the system's user if AMT is enabled. It is up to the OEM to decide whether they want to display the icon or not. Disabling and re-enabling Intel AMT. Intel AMT supports different methods for disabling the management and security technology, as well as different methods for re-enabling the technology. Disabling Intel AMT. AMT can be partially unprovisioned using the configuration settings, or fully unprovisioned by erasing all configuration settings, security credentials, and operational and networking settings. A partial unprovisioning leaves the PC in the setup state. In this state, the PC can self-initiate its automated, remote configuration process. A full unprovisioning erases the configuration profile as well as the security credentials and operational/networking settings required to communicate with the Intel management engine. A full unprovisioning returns Intel AMT to its factory default state. Re-enabling Intel AMT. Once AMT is disabled, in order to enable AMT again, an authorized sysadmin can re-establish the security credentials required to perform remote configuration by either using the remote configuration process. This probably means that AMT is always listening to open ports to the wild and cannot be disabled at all. Physically accessing the PC to restore security credentials either by USB key or by entering the credentials and MEBX parameters manually. Returning AMT to factory default. There is a way to totally reset AMT and return into factory defaults. This can be done in two ways. Setting the appropriate value in the BIOS. Clearing the CMOS memory and/or NVRAM, setup and integration tools. Setup and integration of Intel AMT is supported by a setup and configuration service, an AMT web server tool, and AMT Commander, an unsupported and free, proprietary application available from the Intel website. See also. References. External links.